let's look at load calculation on bolts. First load is Fi, which is a preload. That preload is put in the joint to create the joint Fi, and it will give you tension on the bolt itself, and same preload is applied on the members as a compression. To keep the two plates together. And then when you put this in operation, the purpose of this joint is to keep the two plates together using this preload, and also to overcome any external load that's trying to separate the two plates or the two members. So external load, P, is divided into two portions. Portion will be carried by bolts, and portion will be carried by members. And the total is my external load. So external load is always trying to separate the two plates. Part of it is carried by bolts, and part of it by the members. Okay. Now, total load on bolt is summation of these two loads, preload and external load carried by bolt, because they both on the same direction, so we just add the two loads together. For the members, we have compression from preload and we have tension from external load. So the direction here is opposite, here or here. So the net is force or load on members. Now, as I said, P is actually divided into part carried by bolts plus load carried by members. So a fraction of load carried by P can be calculated if you know this C, and the same for bolts. Okay, so in the bolted joint, the extension due to load and the bolt is equal to contraction or compression on the members. So this delta is the increase in length for bolts and decrease in length for members. So from this relation, since delta is the same, we can say we can also subtract this formula. This can be used here to find the stiffness constant. This is very important for bolts, very important design for design. Okay, so this stiffness, if you follow the formula, C is coming from KB and Km. We aim for 20% or 0.2. So C of 0.2 is a good design target. Okay, now the tensile load, stress can be calculated, safety factor can be calculated, load factor can be calculated, and separation factor also can be calculated. For stress on bolt, we use for stress and bolt, sigma bolt, we use force on bolt and cross-sectional area from the table, AT. And for the yield factor, we use proof strength from the table, if you know the material class and diameter, and sigma. So stress must always be less than proof strength to give you factor of safety of larger than 1. Load factor is the ratio between, this is load carried by bolt, and this is total or maximum allowable load minus initial load. So maximum allowable load minus initial load must always be greater than load carried by bolt to ensure no separation, or to give you very good load factor. For separation, initial load you're putting on the bolt when you fasten the joint, this initial or preload must always be greater than any external load will be carried by members. If external load is greater than initial load, then separation will happen. Two types of joints. For non-permanent joints, we use 75% of the proof load. For permanent joint, we use 90% of proof load.